All right, let's talk about that little number on your phone, the ETA, the estimated time of arrival. Why does it feel like it's just making things up sometimes? Well, we're going to look at that. But more importantly, we're going to look at the incredible AI that's finally making it tell the truth.
I mean, you know exactly what I'm talking about, right? You're watching that little car icon for your food or your ride, and the ETA just dances around. 5 minutes. No, wait, 7. Oh, back to 4 again. It's super frustrating. But it turns out predicting the future, even just a tiny slice of it, is way, way harder than you'd think.
And for a company like Uber, getting that number right is so much more than just keeping you happy. It's a massive multi-million-dollar obsession. Seriously. That little number dictates prices, it decides which driver gets your ride. It's the glue holding their entire system together. So when it's even a little bit wrong, well, you multiply that by a billion trips and it becomes a huge financial problem. So what's the fix? Well, here's the clever part. You don't just scrap the whole system and start over. Instead, you build this brilliant AI that acts like an expert editor. It takes the map's first best guess, and then using a deep understanding of the real world, it cleans it up and corrects it.
Okay, so before we dive into how this AI editor works, we really need to get why the first guess is so often wrong in the first place. What is the map missing?
So, every ETA starts its life inside something called a routing engine. You can just think of it as a super smart calculator. It looks at a perfect digital map, factors in things like traffic, and then computes the absolute fastest path from point A to point B. It's all based on these things called shortest path algorithms. The key word here, though, is perfect. This is the best-case scenario, the first draft, in a world where everything goes exactly to plan.
But of course, the real world is, well, it's messy. It's not a perfect digital map at all. Drivers don't always follow the suggested route, right? People take wrong turns. And think about this. A food delivery driver hunting for apartment 2B moves completely differently than a rideshare driver just pulling up to the curb. And the big one, that last-minute scramble to find a parking spot? Yeah, the routing engine has absolutely no clue that's even a part of the trip.
And this really gets to the heart of the problem. The routing engine spits out this nice, clean prediction, but the actual time it takes to arrive includes all that messy real-world stuff we just talked about. That gap between the prediction and reality, that's the error, and that's what the AI needs to fix.
Okay, so I know what you might be thinking. Come on, it's just a couple of minutes late. What's the big deal? Well, when you're operating at a global scale, a couple of minutes isn't just a couple of minutes. It's a multi-million-dollar problem.
Just to give you a sense of the scale we're talking about, to build this new AI system, the engineers fed it data from 1.4 times billion trips, and that was collected in just a few weeks. That's just mind-boggling. And it shows you how many tiny decisions, like your fare or which driver gets assigned to you, are hanging on this one little number every single day.
And this is the money shot right here. It's a quote from the engineers themselves. They say that reducing the error by even a tiny amount, like low single-digit percentages, unlocks tens of millions of dollars a year. How? By making the whole marketplace just run better. That's a pretty big incentive to get it right.
All right, so we get the problem, and we definitely get the motivation. So let's talk about the solution. It's a system called DPRTA.
And here's what's so smart about their approach. They didn't try to reinvent the wheel and replace the routing engine. Nope. They just built a really smart machine learning model and put it right after the old system. So the routing engine does its thing, makes that initial guess, and then it hands it off to the AI to refine and correct it before you ever see it on your screen.
This whole technique is called ETA post-processing, and the core idea is brilliant. You basically treat that first ETA from the routing engine as a noisy first draft. The AI's job isn't to come up with a new time from scratch. Its job is to predict how wrong that first draft is, and then simply correct for that error. It's not a calculator, it's an editor.
So how in the world does this AI editor actually work? I mean, how does it know what to fix? Let's pop the hood and take a look inside its brain. Okay, now, this is the full architecture. It's called Deep ReefNet. And yeah, I know, it looks incredibly complicated. But don't let it scare you. We can actually break this whole thing down into 2 brilliant core ideas that are way easier to understand.
Here's the two-step process. First, it takes all the different kinds of information, like the time of day, where you are, what kind of trip it is, and it translates everything into one common language. You can think of them as embeddings. Then, once everything's speaking the same language, a special part of the AI, the interaction layer, looks for all the hidden patterns and connections between them.
So that first step is all about creating what are called embeddings. And the best way to think about it is like a digital fingerprint. The AI gives every little piece of information its own unique fingerprint. Tuesday at 5 p.m. gets a fingerprint. A specific downtown intersection gets a fingerprint. Food delivery versus passenger pickup gets a fingerprint. This way, the AI can compare all these totally different concepts using math. And they do something really clever with location. Instead of just feeding the AI a raw latitude and longitude, they create something called geohashes. What this does is it lets the AI look at a location at different zoom levels all at once. It's like seeing the specific street corner, the surrounding neighborhood, and the whole city grid all at the same time. This helps it spot patterns on both a micro and a macro level.
Okay, so that's the theory, that's the architecture. It all sounds great on paper. But the million-dollar question is, did it actually work? Was it any better? Let's check out the results.
So here they pitted their model, Deep RETANet, against some other heavy-hitting machine learning models. The number you want to look at is MAE improvement, which is mean absolute error. Basically, it's a measure of how wrong the prediction is, so a higher improvement percentage is what you want. And as you can see, Deep RETANet is the clear winner here.
This chart really drives the point home. You can see DeepRent out in front. Now, that gap between it and the next best model might not look huge, but you have to remember what we said earlier. Every tiny percentage point of improvement is worth tens of millions of dollars. So that little gap, that's a massive win. But wait, there's a catch. Being accurate is great, but it's totally useless if the AI is slow. This thing has to churn out predictions in real time for billions of requests. It doesn't have seconds to think. It needs to be almost instantaneous.
And honestly, this final result is just mind-blowing. This graph shows us the latency, basically the AI's thinking time. Even when it's getting slammed with thousands of requests every second, the median time it takes to give an answer is just 3.25 milliseconds. Let me put that in perspective for you. A human eye blink takes about 100 milliseconds. This thing is ridiculously fast. It's not just accurate, it's efficient enough to run the entire global network.
So the next time you're watching that little car move across your screen, you'll know there's this incredible AI editor working behind the scenes, making that little number just a bit more honest. And it really makes you wonder, right? If AI can tackle the complex mess of a late delivery, what other everyday annoyance is it going to solve for us next?